Hello everyone, welcome back. Um, Today's challenge is a really interesting one. We will be solving Addis Ababa. So before I start, as always, don't forget to follow me on Twitter, don't forget to subscribe, and don't forget to try the challenge on your own. This is the most important thing. If we go and check Addis Ababa, so what do we have? We have overview. So we have verified passwords cannot be too long. Usernames are printed back to the user verification, and this log is attached to the log ID Pro hardware security module 1. So I think he has, or they have, just improved a little the way they do their security. So now we cannot just send passwords that are too long, I think, which can prevent us from overflowing the stack, I think. We also have the usernames which can be printed back to the user for verification. This is an interesting thing. Okay. So if we try to run the program, so what do we have? Let's suppose I'm going to be sending, as always, item wide. So when we send item wide, we see that our name comes back and the entry is not valid. So if we try to reverse engineer the code statically, as we always do, so do we have? Yes, I'm gonna be searching for the main. So if this is the main, there's no login function now. Okay, interesting. So what do we have? So we are going to be adding this offset to the this negative value to the stack pointer, just aligning things, I think. And then we are going to be clearing the top of the stack. Then we are going to be pushing this value. I think this is basically an address to a string, I think, or to a message. Let's just check this address, which is 44E6. 44E6. What do we have at 44E6? Yes, it is. I suppose it's logged in with username and password. So this is basically printing the message. Let's say welcome message. This is basically printing the um, yes, this is just another just message. So what do we have also? So once we move that to the stack to the top of the stack, we print it. So basically there is an interesting thing in this challenge, guys, which is the printf. So basically in the majority of the challenges that we have worked on microcorruption, we've been always using puts as a function to print the characters to the output. Printf is now a, let's say, a new function that we will be working on. So what do we have? So we're gonna be incrementing the stack pointer. We're gonna be moving. So we are starting to read the username, obviously, reading the username. So basically, in here we are just clearing what we have just pushed, since we are incrementing the stack pointer, and we are basically reading 0x13 bytes of data, which is equal to 19 bytes, I suppose. This is the destination address, as always. Yeah. So what do we have? So we also have that we're going to be moving the stack pointer to the register 11, and then we're going to be incrementing the register 11. Okay, and then we're going to be copying the username. So copying the username to stack pointer plus 2. Well, this is the address that we're going to be copying the username, basically because we have moved to the register 11 the stack pointer, and then register 11 plus equal to 2, and then this is the source address, and this is the destination address, which is basically register 11 plus 2, which is stack pointer plus 2. So basically we are copying the username to stack pointer plus 2. Once we do that, we move the username to the register 15 and we test. So we test the password or the username, I'm sorry. So we basically test the username. Yeah, and then we move the result to the top of the stack. So move result to top of the stack. And then once we move the result to the top of the stack, we push the register 11. So mainly, if we go back a little, we see that the register 11 is having the stack pointer +2, which is basically pointing to the username. So pushing the username and then printing the username. Once we do that, we increment the stack pointer and we move 0xa, and we basically print. This is just printing a end of line character. And then we test if the byte at the top of the stack is equal to 0. So if it is equal to 0, then if it is equal to 0, then we won't open the door, obviously, because we're going to be jumping to the current address plus 0x8, which is this one. And this should be another message. Basically, we're going to be checking that. So if the stack pointer is different to 0 or is equal to 0, then jump to this address, which is this one. Otherwise, we call the unlock door and we jump to the end of the function. Yes, which is this one. We just clear up the stack and just strap the program execution. So just by trying to reverse the code, basically we have stuff just to say. Well, the first thing, there is no left check as the previous challenges, and we have to find a vulnerability inside this code in order to exploit it. So before we try to find the vulnerability, so the vulnerability is pretty obvious, since the way that he's been trying to print stuff in the previous challenge has been puts. He keeps using puts. Now this time he's using printf, so obviously the vulnerability should be in the printf. Now the thing is, you have to know a vulnerability called format string vulnerability. So let me just explain it for you a little. So I have tried to create this little code for you so that you can understand what string format vulnerability is. So basically, the usual way that you would try to print stuff, use for example in C, is just by using printf. For example, you say hello there, and you basically give your name. Let's say for example that one, and you just give your name. For let's say for example your name is um, let's say for example your name is gonna be a 10 characters name, which is, let's say, I don't buy it. So for example, if you try to print your name, you usually would do that just using this code, and you have to add 10 to make sure that the input is just gonna be writing 10 characters to the output. So just sanitizing the stuff. Anyway, so this is the usual way someone would do it. But imagine we are gonna be doing something like that. Imagine we do it like this without using the specifiers or the formats. So basically, I'm gonna be trying to pass down the variable directly to the printf. So what would happen if we do that? So this is a really interesting thing. Why? Simply because when the printf is going to be called, it's going to be checking. Let's say for example I'm going to be calling printf like that. I'm going to be calling it hello there, and I'm going to be adding %s. But I'm not going to be passing any variables to the printf. So how the printf is going to be knowing that it has to write item byte. So here's the thing. So printf basically, guys, when it did not find any kind of variable for the specifiers that it has in the first argument, basically it starts using the stack. So if we try to run that, I have tried to implement such a code that can do that directly without doing that manually. So if we try, for example, I have allocated a buffer with a 100 characters and we have to send something to the input, and basically I'm going to be using this dangerous function, which is gets, to just get as much as I want of data. And then I'm gonna be printing the buffer directly without using any specifiers. So basically the specifiers are gonna be in the input. So just to try the code out with you, if we try to run it, for example, code, so let's say I'm gonna be sending item byte. So if I send item byte, basically I have my input just back to me. But imagine now I'm gonna be sending a percentage s instead of or a percentage x instead of using item byte. So basically I'm gonna be trying to send item byte and space with a percentage x. So what would happen? So what is this strange value? So this value, guys, is coming from the stack, and somehow he's printing this item byte and then he's printing some value from the stack. Why? Simply because if we try to just put that aside um, with the input that we have in front of us, so basically if we try to do that, so this is what I did. I basically tried to do that item byte with a percentage x. There is no variable to be associated with the percentage x, so that's why it's going to be using the stack. So using this way, so we are leaking values of the stack, and we are doing also some jumps of the stack. So for example, if I try to run that, for example, with several percentage x's, what would happen? What would happen if I do that? Let's say I'm going to be sending several percentage x's. So basically, I'm starting to leak values of the stack. So this value is in the stack, this value is in the stack. So all these values are in the stack. I can use also percentage %p to get the actual address of the stack, or the offset of that value on the stack. So if I do that, I get actually some also interesting values. Yes, as you can see. So all those are interesting values in the stack. But right now I'm using the pointer formats. Anyway, just to go back to the code that we have. So this is basically how we can leak data of the stack, and we can jump on values of the stack. The interesting thing, guys, if we try to just run the code one more time and try, for example, with the percentage x. So we have all those values. The interesting thing is that we can see this is some value in the stack, and the other thing is that even the buffer is in the stack. So basically I'm starting also to leak the content of the buffer. So this is basically so if we do bytes from hex of this one, so this is basically a percentage x. As you can see, all those are percentage x's. We can just check that one more time. Um, as you can see, all the percentage x's are just on the stack too. So basically, here's the idea. To do such a thing, we learn now how we can read arbitrary data off the stack. Now, the interesting thing is that we can also write data to the stack. How can we do that? We can use, for example, percentage %n to do that. So basically, if I wanted to test this code with you, so to test this code, so basically I have created a value. So I'm going to be printing hello and then a percentage %n, and then I'm going to be passing the address of the value variable, and then I'm going to be printing what's in that value variable. So the thing is that when you print hello and a percentage %n, he's going to be printing hello for you, and then he's going to be, once we get to the percentage %n specifier, he's going to be calculating how much data did we print to the output, and then he's going to be forwarding that value to this address. So let's just try that out. So what do we have? So we have to recompile the code. Okay. So yes, so this is a hello, which is 5 characters, and then we have forwarded that value to the value variable, and then we have just printed the value variable, which is 5. Now this is pretty cool. Now, what if we get that out? What would happen? The same thing would happen. We're simply gonna be writing hello, and then we're gonna be checking what is the offset that we want to write to. Since we did not give any kind of offset or address to write to, he's gonna be checking the stack, and gonna be grabbing some address of the stack, and then choosing to write 5 to that address. This is interesting. Now, if we go back a little and just try now to solve our challenge just using the percentage x and the percentage n, what can we do with that? So just going back a little, if we try to send, for example, I'm gonna be trying to set a breakpoint first at the printf. Um, what is the printf? Wait a second. So this is a get char. This is the main. So this is the printf. Yes. So I'm gonna reset that, and I'm gonna be sending iron byte. So basically, if we go and check the item bytes, we see that in the stack right now, what do we have exactly? So we have item byte, which is this one, as you can see. So this is item byte, exactly what item byte is. And the interesting thing also is that um, we also have push something before the printf, which is this one, which is the register 11, which is having 38 BC, which we have pushed down. So the stack pointer before pushing that register 11 should be in here. So those are the zeros that he's gonna be checking after on. So if we can change, for example, the value of those addresses or this offset exactly. For example, if we can change, let's say, if we can change this 0 into a 1 or into a 2 or anything else despite being a 0, then we can bypass the check that's going to be happening in here, which is this one. Because he's going to be testing if the top of the stack is going to be 0 or not. Forget about this value because he's going to be cleaning up that back, and the stack pointer should be back to this place because it was in here, and he obviously changed because he pushed something before calling the printf, which is obviously this offset. Basically, 38 BC is basically this address, which is this one, which is the beginning of the username that he's gonna be printing off. Now, using the same methodology of the format string vulnerability, we're gonna be trying to craft something that can jump in the stack to an address and then write some value to that address. So the first step to do is to know what address are we gonna be writing to. So we're gonna be writing to this address, right? Which is this one, which if we wanted to calculate, which is 38B0, this is a 1, 2, this is a 4, this is a 6, this is an 8, this is a 9, this is an 8, and this is a B. So basically we have to write to the address 38BB. So if we try to go to Python, so what do we have? So payload should be um, should be so since we are going to be writing to the address 38BB, and since we are using little Indian as always, we're going to be sending to BB, um, and percentage, and then 38, I suppose. So once we do that, we are now having the address that we're gonna be writing to. The next thing to do is now we gotta jump in the stack to that address, or to actually, um, yes, actually to this little address. Since this address is gonna be stored in the stack, we gotta jump to that address, and then we're gonna be using the percentage n. So how many jumps do we need to get to this output is basically just basically I use fuzzing to do that. Basically, I try to say, let's say I'm gonna be sending 2%x's and see if that is gonna be hitting the address that I'm gonna be writing to, which is this one. So in this case, I'm gonna be just sending percentage x, just one simple percentage x, and check if that value is gonna be hitting the address that I want to write to. So by using this percentage x now, once he's gonna be printing that, so he's gonna be printing this this value, and then he's gonna be printing this value, and then he's gonna be checking some value from the stack, grab it, read it, um, and then which are 2 bytes obviously, since the percentage x in this architecture is just using 2 bytes, so he's basically gonna be reading 2 bytes. And then once I do that, I'm gonna be trying to write 2. So basically, I'm gonna be trying to write to the 0x2 basically, which is 2 bytes, because I basically printed just 2 bytes, which are the 0xbb and the 0x38 to that address. So basically, this is the address that I'm gonna be writing to, and then I'm gonna be using the percentage x to jump back to this offset to basically this address, and then I'm gonna be using the percentage n to write to this address too. So basically, this is the payload. So if I just try to write it, so this is the payload. And what also, I'm gonna be hexifying that value to this one. So if we reset, if we check the hex encoded input, now check that value. So we have BB38, which is now the address that we're gonna be writing to. This is the percentage x, and this is the percentage n. Now, if I try to set a breakpoint after the printf, so after the printf reset, so let's suppose I'm gonna be sending that one. Okay, so after the printf, wait a second, what is the problem? Okay, what is the problem? What is this code is executing exactly? It's in the printf. Percentage x and percentage n. Should be okay, I think. Let me just refresh the challenge and see if the problem is because of the challenge or not. So if I'm gonna be sending this one, there's a problem with this one. Load address unaligned. Wait a second. 38BB. It's unaligned. Why? B C D E. I think I made a mistake. Wait a second. This is F. This is an E. This is a D, and this is a C. It should be an A, I suppose. It should be an A, yeah. Okay, this is supposed to be an A. Yeah. Let's try that out. Yes. Entry is invalid. Let me just try to set a breakpoint there. Well, it's not an AA, it's... Oh my goodness, it's a BA. It's a BA, yeah. It's a BA. It should be a BA. Yes, and as you can see, we have changed the value into 2. I was just having some issues with the address, I think. Oh my goodness, I had... this is what happens when I try to debug everything on my own. Yeah, I just made a mistake first. I just set this address to, which is BB, which is the wrong address that I'm gonna be writing to. It's supposed to be BA, 38BA. So this is basically 38BA. Um, I hate just counting manually. It's just I hate that. So basically, this is BA. I usually use hexdump to do that, but when I do it manually, I never know the positions of the of the variables just using the hexadecimal, um, the hexadecimal immersion system. Anyway, so yes, so basically now this type pointer has been changed, and we continue. We have just unlocked the door. So I hope you have learned something new just by using the format string vulnerability. So if we try to solve that on this server, we can just send that, and we are cool. So don't forget to follow me on Twitter. Don't forget to subscribe to. We are moving forward to completing the micro-corruption challenges, all of them basically. And yes, have a nice day. Bye.